Hello, welcome to Dr. Azad Nabidar. So this today we'll be studying regarding the signal flow graph, how different type of problems appear in the competitive exams and how they are simple. Now to be frank enough, सच बोलने की बात तो ये है, I'm putting this video in the YouTube, but the thing is that until and unless you don't study particularly your subjects, okay, so it will not help you in the longer run. In order to like really understand the concepts and other stuff, you have to go for the book. Myself, I'm following 2 3 books in order to get to the concepts, and only if you are going reading some good books, one Indian book, say for example in this particular chapter, I'll like you can read BCQ, okay, or you can read this book of Hassan Saeed. I'm not promoting any book, or Indian book also, Bakshi. You can, but it's not that good a book. Okay, for some portions you can go for it. So I'll suggest one foreign and one Indian book you should read before just blindly following things on YouTube. Let's get started with this question. Find the transfer function y of x, x of f, s of the system. So look at the system, don't get confused. So it is telling you that you need this y of s by x of s. So it's a very simple question. It's come in the GATE exam. I don't know which year, but see here, this signal over here is getting multiplied. H into y of s is going here. So here x of s is coming. So here if you look, you will get x of s minus h y of s. Let's eliminate this s for some time. Let's not write this s in simple terms. Okay, this is the Laplace. Let's write in the terms of x and hy only. So here also you see this y term is coming over here. So here also you'll get x, okay, minus hy. And finally, if you see over here, this x minus hy, if the blocks are in series, will get multiplied g1. And here also if you see x minus hy into g2. So finally, what is this? This is basically y. Y would be equal to x minus hy into g1 plus x minus hy into g2. Now separate these terms in terms of x and y. If you separate these, so if you clearly look here, so x can be separated. It can be written as x g1 plus g2, and similarly here it can be written as minus of hy can be taken outside, minus hy g1 plus g2, which further can be taken this side. This can be written as y plus hy g1 plus g2, and here it can be written as x g1 plus g2. So if you look at the problem, you can take the y inside, you can write 1 plus h g1 plus g2 is equal to x g1 plus g2. Now if you want y by x, it's simple. Y by x would be equal to x g1 plus g2 divided by 1 plus h g1 plus g2. So this is the solution, and you can clearly see the C point gives the answer. Now let's go to this problem. Very interesting problem. This has been asked recently in the GATE examination of ECE. For the ECE branch, it has been asked. So recently concluded 2023 5th Feb exam has been asked. So what it states that, okay, there are two inputs are there in this particular problem, and it is asking us to give the response of the inputs if they are taken separately. Now for example, let's take the first input separately and eliminate the second input. Now if you look at the first input here, this is r of s, okay, that's just super using the principle of superposition, and here you have this. We will not consider the input, second input. This is plus minus, okay. So now we have g of s and we have y of s. Here we have h of s in the feedback, which is going here, h of s, okay. This is the same symbol of h of s here, okay, and similarly minus 1 is going from the same point here. So you can see minus 1, although it is not in the shape of a block form, but you know that if there's nothing, it is considered to be unity. So let we keep as a block 1. So you see H and 1 are two blocks which are in parallel. So in parallel, what will happen? These blocks will get added. So the combined block diagram that we will be left with would be G of S, and added blocks are 1 and H of S. So this is Y of S, and here we have a block in feedback 1 plus H of S. Okay, this is a block in feedback, and here we have R of S. So it's a minor feedback loop. You know that it's in minus plus. So this minus feedback loop will give you G of S 1 plus G of S H of S. So here the value of G of S is as it is G of S, but the value of H of S is 1 plus H of S. So you substitute there and you will clearly see G of S remains as it is G of S. Instead of H of S, you will get 1 plus G of S. Instead of H of S here, you will substitute 1 plus H of S. So 1 plus H of S. So if you just break down this block, so you get the value of G of S 1 plus G of S plus G of S H of S. So this is the value of G1 of S. Now if you look at this problem, are you having this for G1 of S anywhere? Yes, for G1 of S you are having it here, that is G of S 1 plus G of S G of S H of S. So you are having here, but you are also having at the option A. So now you have to confirm. If it was not in any other option, you would have directly marked A, but it's also there in G2. So now you have to calculate for the response of D of S. So this is a competitive exam trick. If it was not there, you would have directly marked here. Now let's see about this. Now here also you have to consider the response only due to D of S. In order to consider the response only due to D of S, what you will be doing is that in terms of the in terms of the D of S, again, if you look for the D of S term also, same principle will apply in the terms of D of S also. Again, these blocks will become in parallel. See here, if you only consider due to this, so only thing is that you have to remove this. Rest similar thing will follow. See, D of S, instead of D of S coming here, because this only thing is that input you have negated. So this will become G of S H of S. Again, this is in parallel, so it will follow the same pattern. So hence it would be again equal to G of S 1 plus G of same thing. So your G2 of S would be also in a similar manner the same answer. So hence this problem is similar to this. Now let's look at the third problem over here. So how the third problem would be taken into the consideration. Now as far as the third problem is concerned, it is looking little complicated, but if you convert it into the signal flow graph, so you look at the signal. If I write this as my input, I make a block diagram into signal R of S. I take this signal to wherever my summation blocks are there and my input blocks are there, I make it as a node. Here also a node, here also a node. So I have total number of 4 nodes. So this is a summation block over here. So one more node. After the summation block, I have 1 by S. This is a node 1 by S. After that, I have a node over here, and this signal R of S is from here, it is coming, here it's going. This is the signal of 3, and again finally I have a node at Y of S, and this Y of S, this node Y of S, if I clearly notice, it is going back, it is going back here as 1. Okay, it's a positive feedback. You just look, it's +1. Now if you, it's in my signal flow graph. If I look at this graph and apply the Mason's gain formula, which I've already taught you, what does the Mason's gain formula state? Pk del k by del. What Pk, how many number of forward paths it's having? Let's see. This is the one forward path, and the another forward path is this. So we have two forward paths. One is from 2, the one is, I just color it for you. So we are having two forward paths here. One with the black color I will give. One forward path you can see with the black color, right? This is the forward path, and the value of this forward path P1 would be equal to 2 by S. And where is the other forward path? What is the color of that? Let's see. Let's keep it a different color. So see, another forward path is like in the blue, right? Like this and this. So another forward path, that is P2, its value is 3. Now which are the loops that I'm having. Loops is at one point I'll start and I'll come at another same point. So I'm having only one loop, and you can see clearly the loop is this. This is my loop over here. So the value of this loop 1 is equal to 1 by s. So all the forward path 1 and path 2 are touching it. Hence the value of delta 1 would be 1. Same thing, delta 2 be 1. And what is the value of del? Del is 1 minus sum of individual loops. Sum of individual loops. Okay, individual loops. So I'm having only one loop, so del would be equal to 1 minus 1 by s, and I'm having nothing. So I can just, from the Mason's gain formula, if I need y of s by r of s, I can directly write, okay, p1 del 1 plus p2 del 2 divided by del. So the value of p1 is, I just showed you 2 by s, okay, and the value of the p2 is 3, and del is 1 minus of 1 by s. Now if I solve this, this would be equal to 3s plus 2, right, divided by s, divided by s minus 1 by s. So this s and this s cancel, so I'm left with 3s plus 2 s minus 1. So I am having 3s plus 2 and s minus 1. This is the answer to this question. So this has been asked again in the ECE for the 2023 GATE examination. So hope that you have understood some of the questions, how the GATE is following. Let's go for one more problem. This is a very interesting problem. This repeatedly is getting asked. So look at this problem over here. It states that this x1 is 0. So this means if this x1 is 0, so this graph will now get modified. How does this graph gets modified? This graph gets modified into, only part that is remaining is this. And now instead of going here, it will become here. So if I have to redraw this, this will become a self loop over here. So now if you look at this, so you have a point over here that is your x2, and this is the point that is g1. Okay, and the value of the g1 is going like this, so it is becoming minus g1, and here you are having as g2 and g2 of minus 1, and this is my this is my y of s. Okay, now I want to, I want to, if you look at the forward path, there is only one forward path, that is g2. Okay, that is my only, if my p1 is only one forward path is g2. Now loops, there are two loops. One loop is this one, that is minus g2. Okay, another is the self loop, that is loop 2, that is minus g1, and all the loops are touching everything. And if you look forward path is, so again apply the Mason's gain formula, so you get p1 del 1 is equal to, again you see, p1 del 1 by del. So del 1 is all again equal to, because all, there is no combination of the loop that is not touching it, so del 1 would be equal to 1 again. So this is like p1 is equal to g2 and 1 minus sum of the loops. So what is the sum? Minus g1 minus g2. So this will become g2 1 plus g1 plus g2. So do you have any example of this? G2 1 plus g2, yeah, p1 del 1. Okay, wait, hold on a second. Let's see why we are not getting any options here. It's very late in the night, guys. Yeah, so same thing, where we have made mistake. Here if you look at the loop, uh, this one loop is g1, it's correctly, and any other loop, yeah, okay, yeah, see here is the mistake. Here the loop has to be, if you look at this loop over here, first the diagram over here, so this is g2, and because of this point is g1, so this has to be g1, right, minus g1. I'm sorry for the mistake, this is g2, and if I make that G1, so this will become minus G2. So now my loop 2 becomes, if loop 2 is minus G1, no problem. This is minus G1 G2, right? This is basically minus G1 G2. So the sum of the loops would be, due to this, would be minus G1 G2. Here also it would be G1 G2. So I can clearly state that this is G2 1 plus, I can take the G1 out, and this will be 1 plus G2. So this is the solution to this question. I hope you have understood it. Thank you very much. Let me stop this, and hope we'll be meeting soon again. Thank you very much.